thank you. So I was involved in chapter 3, which was looking at the sort of left-hand petal, if you like, of the diagram that you were just looking at. So changes in climate extremes and their impacts on the physical environment. So the kind of events we were looking at were events related to temperature and rainfall and to wind. We also looked at what we call phenomena, so things like the El Niño Southern Oscillation, monsoons, tropical cyclones. And we also looked at sort of direct physical impacts, so in particular drought, floods and extreme sea level. So one part of our work and our chapter was looking at the evidence for observed changes and focusing on the period since 1950 where there's more kind of observed data. But this assessment was very much kind of constrained by the availability of observed climate data, observed weather data, the spatial distribution of that data and the quality of the data. In some cases, you'll see that we make quite sort of confident and sort of robust statements about changes that have occurred. So particularly in the case of extreme hot days, we conclude that it's very likely that there's been a global increase in extreme hot days and a decrease in cold days and nights. For other types of events, we're somewhat less confident. So, for example, we consider it likely that there's been increases in heavy rainfall events in more regions of the world than there have been decreases. In other cases, we have low confidence and can't say anything even about the direction of change. And tropical cyclones is a good example of that. And there the low confidence really comes from changes in observational practices, which means that we don't have a long, sort of coherent, homogeneous record. As well as looking at the actual changes and trends themselves, we also assess the extent to which we could attribute these observed changes to human influences. And again, our level of confidence varies depending on the type of event that we're sort of talking about, and on the spatial scale as well. So we're most confident about global changes in temperature extremes. So for high temperature extremes, we consider it likely that those changes have an anthropogenic, a human kind of influence. In the case of the changes in extreme rainfall, and again this is just at the global level, we have medium confidence that anthropogenic changes, influences are responsible for the temperature, for the precipitation changes. And another part of our chapter then goes on to look at future projections of these events. This is an example of a rather sort of complicated diagram that's in the summary for policymakers. So I'm not going to talk about it in detail. You can go away and sort of look at it afterwards. But this is showing results from global climate models for changes in hot days for two periods, for the middle of the century, which is the sort of first cluster of bars in each case, and then on the right-hand side for the end of the century. And what we're actually looking at here is what we call the return period, where it's events that currently have a return period of 20 years. So on average, you'd expect these events to happen every 20 years. And what this diagram shows you is a consistent decrease in that return period. So it's telling you that that hot days are becoming more frequent. And in fact, if you look at this globally, we're virtually certain that hot days will increase in the future. So in many parts of the globe, what's currently a 20-year event happening on average once every 20 years becomes a 1 in 2 year event. So quite a major increase in frequency of these events. The other thing that figure sort of shows you is that the future changes are larger with higher greenhouse gas emissions. So it's probably quite hard to sort of see, but if you compare the blue boxes, which are for a low emission scenario, compared with the red one, which is the higher emissions, is giving you much larger changes. The next example, this is now for heavy rainfall events, so kind of laid out in the same way. And I should say that these sort of sub-regions that you can see here, so for example Western Africa, Southern Africa, these are the sort of regions at which we did our assessment. We don't actually in the report go to sort of smaller scale regions, which was partly a matter of sort of space. So again, we're looking at heavy rainfall events with a 20-year return period, and we're seeing increases in the frequency of these events, particularly at high latitudes and in tropical regions. So over large parts of the globe, what's currently a 1 in 20-year event is projected to occur every 1 in 5 or 15 years by the end of the century. But you can also see that the kind of the spread, so the kind of height of the bars, is actually larger in this example for rainfall than it is for temperature, and that's an indication of greater uncertainty in the rainfall changes. And I think one kind of novel sort of thing about this assessment, I think that we've across all the chapters, we've assessed uncertainty in a much more transparent and rigorous way than has been done in previous IPCC reports. We were all working with some new guidance on communicating and representing uncertainty developed by the IPCC, which will also be used in the 5th assessment report. And what this entailed doing was kind of looking at things in 2 stages. So first was assessing our confidence in particular statements. In the case of the climate projections, this depends on the agreement between the climate models, different climate models, and how well those models simulate the present day. But also it depends on the amount and quality of observed data that we have for a particular variable, and I think crucially an understanding of the underlying physical processes. So it brings in sort of expert judgment. And we sort of categorise events, or statements, as to whether we have low, medium or high confidence. And that confidence varies from variable to variable, so it's higher for temperature than for rainfall. It also varies from region to region and even from season to season. And in the cases where we have high confidence in the underlying evidence, we then are able to move on to the sort of second stage, which is assigning quantitative measure of uncertainty, so giving some probabilistic statement or some likelihood statement. And this is partly based on statistical analysis of things like these sort of model results, but also again on expert judgment. And just to give you an example of how we kind of use this, for example, in the case of Southern African drought, we conclude that we have medium confidence in an increase in drought in the future. For East African rainfall, we actually have high confidence, so we're able to make a likelihood statement, and in this case we consider it likely that there will be an increase in extreme heavy precipitation events in East Africa. And this equates to a sort of a quantified kind of range. So likely means, in IPCC terms, means 66 to 100% probability. So as I say, I think the new uncertainty guidance provides a very clear framework, and hopefully it makes it easier for readers and decision makers to see where we have, where certainty is high, as well as able to identify where the remaining areas of uncertainty are.